To record the best possible audio in Adobe Audition, you need to take care of several things. We will cover each one individually. The first important thing is to select the correct microphone. To check which microphone has been selected for recording, go to Adobe Audition Settings. In Adobe Audition Settings, click on Audio Hardware. The default input is your microphone selection. If you do not see the correct microphone selected as default input, please select it from the drop-down. You also need to have an idea of what name your microphone is appearing under on the list. For example, I have a Sennheiser microphone connected to my computer through Scarlett 2i2 USB audio interface. Selecting the audio interface means selecting the microphone attached to it. For you, the microphone may be connected through a USB cable, or you may be using a different audio interface or mixer. Whatever it is, make sure the correct name is selected as the default input. It is a very common mistake to record with the wrong microphone. Recording with the wrong microphone will lead to poor audio quality, and you have to record again. Always remember to check the microphone before recording. Because it is related to system settings, and if the microphone is disconnected from your computer somehow, this selection will change automatically. To be safe, always check audio hardware before recording. If you do not see your microphone on the list, ensure it is connected to your computer and then restart Adobe Audition. I will keep all other settings as they are and move to the next configuration. Once you have checked microphone selection, check the input level. There is a meter at the bottom in Adobe Audition. Double-clicking inside the meter area will show its current level. Of course, you will see this level while you record, but you can check it before recording to make sure everything is okay. While you talk, the meter level should be between -18 and -6 dB. Being in that range means you are getting good enough audio data without distortion or clipping. They also show some levels in yellow and red. Yellow levels mean you should be cautious as you are quite close to clipping. The maximum reading on this meter is 0 dB. If you record beyond 0 dB, your audio will sound clipped and distorted. Oftentimes, those audio are not recoverable, resulting in poor audio. If you can be in the range of -18 to -6 dB, you will have enough room for post-processing and will get high-quality audio after processing. To achieve proper levels in the meter, you have to talk from a proper distance, usually 4 to 6 inches from the microphone. You also have to adjust the gain in your audio interface or microphone to hit the desired level in the meter. Once the microphone has been set and the levels are okay, you are ready to record your session. You can either open a new audio file from the file menu at the top, or you can hit the red record button. Once you hit the record button, you can set some configurations for the audio file. The first configuration is the file name. You can set a file name if you wish, or you can do it during export. I will do it during export, keeping the file name as it is. After the file name, you see the sample rate. For voice recording, the sample rate should be 44.1 kHz, and that is also the default value. There is no good reason to change it for voice recording, but many people change it due to wrong or misinformation. We are dealing with voice recording, and there is no good reason to choose a sample rate other than 44.1 kHz. A lower sample rate will degrade the recording quality, while an upper sample rate won't make any difference for our use case. Instead, a higher sample rate will require a lot of hard disk space. So the bottom line is to record in 44.1 kHz, and that would be good for audiobooks, podcasts, and voiceover. The next field is recording channel. You should record in mono. For voice recording, you don't need stereo recording. Recording channel other than mono can introduce some complexity. To keep things simple, always record in mono. Then comes the bit depth. The bit depth should be 32-bit float. Once again, many people change it without understanding what they are doing. There is a lot of misinformation out there, and people modify it without understanding the consequences of their actions. 32-bit float is the safest option for recording your voice. In summary, you do not need to change the default configurations for these fields. However, many people are misinformed about these settings, so I discussed them in a bit of detail. I will now click OK, and the waveform of the recording will appear. Please note that the volume level of the recording will be quite low compared to the current narration, but don't worry about that at the moment.
I have been teaching audio stuff for a few years now, and I keep hearing the same thing from many beginners. Everything feels too technical, or I don't even know what I am looking for. I get emails and messages all the time from people who feel stuck, who want to record something, but just don't know how to put the pieces together. That's why I created this guide. I have kept everything simple, clear, step by step, no fancy language or confusing instructions. Just the basics explained in a way that actually makes sense. I do offer one-to-one help too, but I know that's not something everyone is looking for. So the goal here is to give you solid help that you can follow on your own, even if you have never touched a mic or opened an audio editing program before.
The recording has been done, and we see the waveform of the recording on the screen. We edit and process this waveform for the final audio. But before that, it is always a good idea to save the original recording. There are two options to save the audio just after recording, using the Save or Export option in the File menu. I haven't saved any audio file from yet, so I will use the Save option. Please note that both Save and Export will work. You will get a pop-up window with different configuration options. For example, you can set the name of the file to save, and the location you want to save. I will save it inside the Audition Samples folder on desktop. You are free to choose your location. I will give the file a name, Recording Test. I will save it as a WAV file. It is always a good idea to save the raw recording or original recording as WAV. Because WAV format is a lossless format and your audio data will be as it is. I will keep the other options as it is and click OK. The file is now saved, and we can check from the location. I will browse to the Audition Samples folder where I saved the file. You can see the recording test WAV file here. I can open this file in Adobe Audition at any later time and do the editing or processing. I hope now you have a good idea of the overall recording and saving your voice. The next step would be to process this recording so that we can get high-quality audio. When you record audio, it doesn't always sound perfect right out of the mic. It might be too quiet, too noisy, or just not ready to be used in a professional project or to be uploaded online. That's why you need to do some audio processing, and to process audio in Audition, you'll use the Effects menu. Inside the Effects menu, you'll find two main types of effects. Built-in effects that come with Adobe Audition. Third-party effects that you can install separately. We'll focus on built-in effects for now. I'll talk about third-party effects later. The built-in effects are neatly organized into categories based on what they do. For example, there's a category called Amplitude and Compression. This includes all the tools that control the volume and loudness of your audio. Each effect has its own settings, and how you configure them depends on your type of audio and the specific problem you're trying to solve. We'll go through the most essential ones. There are also effects for fixing audio issues, like noise reduction. If your recording has background noise, you'll find helpful tools under the Noise Reduction, Restoration section. When learning how to use effects in Audition, you should always follow this three-step process. Identify the problem in your recording. Choose the right effect for that problem. Configure the effect properly based on your recording. Some effects can be used with the same settings every time, but others need to be adjusted for each recording. We'll learn both types as we go. Let's start with the Normalize effect. The Normalize effect is found under Effects, Amplitude and Compression. You can see a Normalize process effect here. When you click on it, a settings window will pop up. There are two ways to normalize audio. By setting a percentage, however, I do not recommend the percentage settings as it is complex to understand. Another way is by choosing a specific decibel dB value. This is what we'll use. So, what does a dB value mean here? You can set the normalization level to something like -3 dB or -1 dB. These are negative numbers because 0 dB is the maximum level your audio can reach without distortion. Going over 0 can cause clipping, which you want to avoid. Now, look at the waveform in your Audition timeline. On the right side, you'll see a decibel scale. The height of the waveform gives you an idea of how loud the audio is. For example, this audio isn't going beyond -12 dB at any point. You have to pay attention to both the top half and the bottom half of this scale. The maximum point of the audio is called the peak amplitude. Through the Normalize effect, we set the peak amplitude of a recording.
With a lifetime guarantee against breakage to back it up. Wait, cutting.
When you normalize, the peak of the waveform gets adjusted to your chosen target. So if you normalize to -3 dB, the loudest point in the waveform will now reach exactly -3 dB. The rest of the audio will scale up proportionally, making the overall volume louder. You can also find shortcuts for normalization in the Favorites menu. There are two shortcuts here, Normalize to -3 dB, and Normalize to -0.1 dB. Normalize to -3 dB is standard practice. When we need to do it, we can do it from the Favorites menu. All the items you see in the favorites menu are shortcuts to specific audio effects. Let's say you click on Normalize to -3 dB from favorites. The waveform will grow in size, and the loudest part will now touch the -3 dB mark, either on the top half or bottom half, or both. This is perfectly normal. For example, on this audio, it has touched -3 dB at the bottom half. If we play that part of the audio, we can also be sure it is touching -3 dB in the meter. If you play the audio after normalizing, you'll hear that the volume has increased compared to before.
With a lifetime guarantee against breakage to back it up. Weight, cutting surface, and speed set us apart.
You see the audio has increased in volume. If I recap what has happened here, you will see the difference. Before normalize, the waveform was smaller in height. I will undo it from keyboard shortcut Command Z. This was the waveform before normalize. I will now redo with Command Shift Z. This is the waveform after normalize. The waveform grew in size because the peak amplitude of the waveform was less than the peak amplitude of normalize. It is not the case that the waveform will always increase in height. Let's see another example to understand it better. Let's open a different audio file where the waveform is already touching 0 dB. I have opened another recording where the peak amplitude is touching 0 dB. There is another way to check the peak amplitude of a recording. You can confirm this by using the Amplitude Statistics panel. Go to Window Amplitude Statistics. You can see a new panel has been opened here. This is the Amplitude Statistics panel. Click Scan, and it will tell you the peak amplitude of your audio. It shows 0 dB as the peak amplitude. If you now normalize this audio to -3 dB, the entire waveform will shrink so that the highest point becomes -3 dB. Again, if you scan it using Amplitude Statistics after normalizing, you'll see that the peak is now exactly -3 dB. So, normalize adjusts the peak level of your audio to a value you choose. If the peak was lower before normalize, it increases it. If the peak is higher before normalize, it decreases it. This effect doesn't distort your audio. It simply raises or lowers the overall volume, based on the peak level you set. A few more important points about normalization. Normalize is safe to use multiple times. You can apply it again and again, and it won't degrade the audio quality. If you use the same normalize setting, like -3 dB, on a file that's already at -3 dB, nothing will change. If you use a different value, the waveform will adjust again accordingly. Normalize only adjusts volume. It doesn't fix noise, echo, or clarity. But it's a critical step in controlling loudness before using other effects. So that's how the normalize effect works. It's not the only tool for controlling volume, but it's a great starting point. You'll often combine it with other tools, like compressors or limiters, to get the best results. We'll explore more effects and techniques as we continue. If you want to learn audio editing step by step for voiceover, audiobook narration, podcasts, or content creation using Adobe Audition, I have an Adobe Audition bundle for you. The Adobe Audition bundle has a beginner to advanced course, and 5 pre-built presets to make your sound better in one click. You will also get a custom EQ and preset that perfectly match your voice. Every voice, microphone, and recording setup is different. To enhance your voice the most, you need a custom EQ that matches your voice. You will get that in the Adobe Audition bundle. You will learn both beginner and advanced tricks of using Adobe Audition from the course. Your audio can be processed with just a click using the pre-built presets. The bundle is available on my shop and my Patreon page at a heavily discounted price. I will give the links in the description for you to check them out. We have seen so far how to record audio in Adobe Audition and how the normalize works. We will now see an interesting effect called the compressor. The compressor effect is a complex effect, but it is a very important effect to control the loudness of the audio. You may feel it is a bit early for such complex topics, but trust me, it makes the rest of the learning easier. Because it is one of the crucial effects to achieve proper loudness of the audio. When you have a properly loud audio, it becomes easy to identify other issues in the audio and fix them. Most people use the compressor incorrectly due to its complex nature. However, once you understand how it is affecting your audio, you will have no problem using it. If I say what the job of the normalize effect is, you would say it adjusts the volume level. What is the job of the compressor effect? The compressor effect reduces dynamic range. If you go to the effects menu, you'll see there are several different ways to apply compression. You will see options like dynamics, dynamic processing, multiband compressor, single band compressor, and even a couple more. All of these are methods of compression, and they each have their own use cases. But for this lesson, we're going to focus on the simplest one so you can clearly understand what compression does before experimenting with more advanced variations. So, what exactly does a compressor do? When you look at a waveform, you'll notice that some sections are taller, these are the louder parts of your audio, and some sections are shorter, these are the quieter parts. The difference between the loudest and quietest parts is called the dynamic range. A compressor reduces this dynamic range. In other words, it makes the loud parts a little quieter, and the quiet parts a little louder, so the overall sound feels more even. When you reduce the dynamic range, the audio often sounds louder and more consistent to the listener. It's important to keep in mind that judging dynamic range just by looking at the waveform isn't always accurate. Visually, you can sometimes guess, but there's a better way to measure it precisely, and that's by using the amplitude statistics window. To do that, go to the window menu, select amplitude statistics, and then click Scan. This will analyze the entire piece of audio and give you several readings. For compression purposes, the value we care about most is the total RMS amplitude. RMS is a measure of the average loudness of your audio. For professional voice work, especially audiobooks, the RMS should be between -18 and -23 decibels. This is the industry standard for clear, comfortable listening, and it's also the range required by platforms like ACX. In our example, the RMS reading is -23.19 decibels, and the peak amplitude is -3 decibels. The total RMS falls behind the expected range. We need to increase it, and we can do it using the compressor effect. Please note that the peak should be -3, but the RMS has to be increased. That means you have to increase the RMS without increasing the peak, and that's where a compressor effect shines. Now let's actually apply the compression. Go to Effect, then Amplitude and Compression, and choose Dynamics. There are several compressor effects, but the Dynamics is the easiest to configure. First, set it back to the default preset so you're starting from scratch. In the Dynamics effect window, you'll see three main options: Auto Gate, Compressor, and Expander. For this process, we only need the compressor, leave Auto Gate and Expander unchecked. A good way to begin is to select the Soft Compression preset. This sets a basic configuration so you can focus on the two most important controls, threshold and ratio. When you choose the Soft Compression preset, the other settings are okay for voice recording. The threshold is the point at which the compressor starts to work. Currently it is -12.3 dB. The parts of the waveform that cross -12.3 dB will be compressed. If I change the threshold to -13.6 dB, then the parts of the waveform crossing -13.6 dB will be compressed. So, you get the point. Whatever threshold I set, audio levels above that will be compressed. The lower the threshold you set, the more of the waveform will get into the range of compression. Usually, a threshold between -10 and -15 works okay most of the time for voice recording. The ratio determines how much compression is applied once the audio passes that threshold. A ratio of 2 means that for every 2 decibels above the threshold, the output will only increase by 1 decibel. If you lower the threshold, more of your audio will be affected by compression. If you increase the ratio, the more the audio will be compressed. For most voice work, a ratio between 2 and 4 is ideal. Too much compression, however, can make your audio sound unnatural or lifeless. In our example, the audio is already quite uniform, so we don't need a heavy setting. But if you were processing audio with big volume jumps, some parts are much louder than others, you might lower the threshold and increase the ratio to smooth things out. I will apply these settings, and check how it is affecting the RMS value. Once you apply the compression, you'll notice that the waveform's tallest peaks are now closer in size to the quieter parts. This means the dynamic range has been reduced. But compression can also change your peak amplitude, which is why it's important to normalize afterward. You can see the peak is now around -6, which was -3 dB before. The RMS has increased, but we can compare correctly when we set the peak to -3 dB again. To normalize to -3 dB, go to the Favorites menu, and choose Normalize to -3 dB. Please note that when you use a compressor effect, you should use a normalize effect immediately after to get an accurate measure of RMS. I will then go to Amplitude Statistics to scan the audio again. This time, you should see the peak amplitude at -3, and the RMS is -18.8 decibels. This tells us the audio is now louder and more balanced. If the audio feels too loud after compression, you have to undo the compressor effect, and adjust the compressor a bit differently. You can adjust it by raising the threshold or lowering the ratio. On the other hand, if you need stronger compression, you can lower the threshold and raise the ratio. It's a matter of listening carefully and adjusting until you're happy with the sound. Once you get comfortable with this basic method, you can experiment with the other compressor options, like the multi-band compressor, which lets you compress different frequency ranges separately for even finer control. That's how you use the compressor to manage your audio's loudness. For now, I would recommend that you follow this effect sequence: normalize, compressor, normalize. You will then feel how your audio really sounds at different RMS levels and have a better idea of audio quality. So far, you have seen the first part of the Adobe Audition tutorial for beginners. In the next part of this beginner series, we'll explore more effects and how to navigate the software confidently. If you want that next video, leave a comment letting me know you'd like part 2. Practice what you have seen so far, and you will hear exactly how compression changes the sound of your recordings. If you want to learn audio editing step by step for voiceover, audiobook narration, podcasts, or content creation using Adobe Audition, I have an Adobe Audition bundle for you. The Adobe Audition bundle has a beginner to advanced course and 5 pre-built presets to make your sound better in one click. You will also get a custom EQ and preset that perfectly match your voice. Every voice, microphone, and recording setup is different. To enhance your voice the most, you need a custom EQ that matches your voice. You will get that in the Adobe Audition bundle. You will learn both beginner and advanced tricks of using Adobe Audition from the course. Your audio can be processed with just a click using the pre-built presets. The bundle is available on my shop and my Patreon page at a heavily discounted price. I will give the links in the description for you to check them out.